With rising sea levels, soil liquefaction, and increasing flood risks, Japan's Kansai International Airport is battling the elements. It's a testament to Japan's innovative spirit and economic prowess. The airport was designed to serve as a gateway to Western Japan, welcoming millions of travelers and cargo shipments each year. However, its foundation is now under threat. As the airport slowly subsides, Japan faces a daunting question. Can it save its sinking airport, or will rising waters claim this critical infrastructure? Japan's vulnerability to natural disasters is deeply rooted in its geographical location and characteristics. Situated along the Pacific Ring of Fire, the country experiences frequent earthquakes due to tectonic plate activity, particularly where the Pacific, Philippine Sea, Eurasian, and North America plates meet. This high level of seismic activity has led to several major earthquakes in Japan's history, including the devastating 2011 Tohoku earthquake and tsunami, which not only caused immense loss of life, but also triggered the Fukushima nuclear disaster. The most severe challenge came with Typhoon Jebi in September 2018, which resulted in catastrophic flooding and operational paralysis. The storm caused extensive damage to cargo areas. The access bridge to the airport was severely impacted, delaying the evacuation of stranded passengers. The economic toll was significant, with estimates of losses amounting to around $500 million. That situation affected the entire Kansai region. Then, the 2019 Typhoon Hagibis also caused widespread flooding and damage. The construction of KIX was an intricate and multi-year process. It aimed at creating a stable airport on artificial islands in Osaka Bay. To address the lack of land near Osaka and avoid residential noise issues, engineers built the airport on two man-made islands. The first phase of construction began in 1987. It involved significant engineering challenges. One of the major hurdles faced during construction was ensuring the stability of the reclaimed land. The site began as a clay seabed, which is not naturally stable enough to support heavy structures. To address this, engineers implemented a sophisticated process involving the installation of 2.2 million vertical drainage pipes. The island itself required extensive groundwork, starting with creating a 30-foot deep seawall, using 69 enormous steel chambers for the perimeter. These were filled with nearly 48,000 concrete tetrapods to protect the island from strong waves and coastal erosion. The central area was filled with over 430 million cubic meters of rock transported from nearby mountains, a logistical challenge on its own. Over time, layers of soil were added, reaching approximately 65 feet above sea level. Engineers sourced soil from Osaka Bay and nearby mountains, and even imported material from China and Korea to fill the area sufficiently. Settlement management was a crucial, ongoing task. The initial estimations of island subsidence were exceeded, with the land sinking faster and more unevenly than anticipated. In response, engineers installed 900 columns with hydraulic jacks beneath the airport buildings, allowing them to adjust levels as needed. They paved runways with asphalt rather than concrete, which would better withstand shifting ground without cracking. Despite these measures, the airport's maintenance remains complex and costly due to continuous subsidence and the potential risks posed by natural forces like typhoons. The entire construction process, including unforeseen adjustments and additional structural reinforcements, pushed the total cost from an initial $8 billion to over $20 billion by 2008. KIX has been grappling with significant sinking issues since its construction. The airport has sunk approximately 38 feet over the past 3 decades, far exceeding initial engineering projections. When the airport was designed, engineers estimated it would sink about 19 feet over a span of 50 years. This sinking is primarily due to several interrelated factors stemming from its construction and the geological conditions of the site. A significant factor in the sinking is the natural consolidation of the clay layers beneath the airport. These clay layers contain a high water content, up to 70% for soft alluvial clay, leading to a slow process of land settling as the weight of the airport pushes the water out from the clay. This process is akin to squeezing a sponge, where the clay compresses slowly, taking decades to fully consolidate. The weight of the reclaimed land is heavy enough that it exceeds the support capacity of the underlying clay, causing the land to sink gradually. Soft soils at KIX are susceptible to liquefaction, a phenomenon where water-saturated soil loses strength and stability due to seismic activity or vibrations. During earthquakes or heavy aircraft traffic, the water-saturated soils can liquefy, causing the ground to lose its bearing capacity. This leads to settlement, structural damage, and increased risk of flooding. Tidal action also significantly impacts its stability. Osaka Bay's 2-meter tidal range causes regular water level fluctuations, infiltrating soft soils and increasing pore pressure. This reduces soil strength, exacerbating settlement and liquefaction. The repeated wetting and drying cycle weakens the soil structure. Wave action generated by wind, storms, and marine traffic further destabilizes KIX's foundation. Waves erode the airport's perimeter, compromise soil stability, and transmit pressure to the soil, increasing pore pressure and settlement. The artificial islands that make up Kansai Airport were constructed by depositing massive amounts of fill material, as we previously explained. This sediment settles at uneven rates, causing instability. Engineers anticipated some subsidence, but certain sections, especially the areas supporting critical infrastructure, have sunk faster than expected. This uneven settlement complicates maintenance, as runways and buildings may experience differential sinking, affecting their structural alignment and safety. The current situation continues to pose challenges due to the ongoing settlement of the island. To combat this, various mitigation efforts have been implemented, including technological and structural strategies to stabilize the land and protect critical infrastructure. Engineers implemented a jack-up system, particularly under Terminal 1. This system allows for precise adjustments to pillars supporting the terminal, effectively jacking up the structure to maintain level floors and minimize the risk of tilt. This system is monitored and adjusted as needed to maintain the terminal's structural integrity, reducing disruptions to airport operations. Kansai has implemented new flood barrier designs and upgraded its drainage systems to better handle heavy rainfall and typhoon conditions. This includes increasing the capacity of pumps and modifying the drainage channels to expedite water removal from the runway and airport grounds, preventing prolonged flooding. Following the typhoon, the country undertook a significant project to increase the height of its seawalls. The new design includes allowances for future sea level rise, which is increasingly important due to climate change. By raising these barriers, KIX has enhanced its capacity to handle higher than expected storm surges, ensuring that future weather events pose less of a flooding risk to airport operations. To minimize wave impact, they installed wave-dissipating blocks along its seawalls. These blocks help break up and reduce the intensity of incoming waves before they hit the seawall, distributing the wave energy and preventing erosion and damage to the structure. This additional layer of defense improves the seawall's resilience against typhoons and other extreme weather events. Collaborative efforts with companies like NACO and Royal Haskoning DHV have introduced tools like the Circle tool and flood simulation models to resilience planning. These digital tools simulate potential flooding scenarios, helping airport authorities visualize how various assets, such as substations, runways, and terminals, might be affected in future flood events. Through this visualization, the airport authority has been able to prioritize infrastructure investments and fine-tune its response strategies to minimize disruptions. The management has revised its disaster management and business continuity plans, incorporating insights from stakeholders to optimize evacuation routes and communication channels during emergencies. This comprehensive approach aims to reduce operational downtime and enhance coordination among airport staff, local government, and external stakeholders. Regular assessments of settlement rates and sea level changes ensure that any necessary elevation or structural adjustments can be proactively made. This ongoing monitoring is essential to maintain Kansai Airport's resilience in the face of evolving climate changes. This renovation aims to expand the international departure area, increase lounge and retail space by 60%, and integrate modern experiential designs tailored to passenger needs. These improvements will allow the terminal to operate more efficiently and handle up to 25% more international traffic, helping Kansai remain competitive in the region. The renovation process is structured to minimize disruptions, with construction phased through its completion by 2025. Nonetheless, as sea levels rise and extreme weather becomes more frequent, Kansai Airport faces a continual need for updated protective measures to preserve both safety and operational continuity. Only the future will tell us whether Japan can save Kansai Airport. We appreciate you watching this video. Be sure to give us a like and don't forget to hit that subscribe button to catch more great content like this, and we'll see you in the next one.